everyone, welcome back to Tina Teach. In today's lesson about Python project, we're going to be making a game. It's been a while, I think, since we've uploaded a video where we get to play around with Python a little bit, and today's game is going to be ping pong. Now, what we're going to do is we're just going to write a simple logical code where there are two paddles. We control one paddle, and the other paddle, it would go, up and down, back and forth maybe, and it's hitting the ball, and we're going to play ping pong with our computer. It's a fun game for you to code and to learn to master Python, as well as when you're bored, you can perhaps practice your reflexes when it comes to, playing ping pong. As usual, we're going to import some modules. Import Pygame is necessary because it is a Pygame. Import sys, import random. First of all, we're going to initialize Pygame with pygame.init, paddle width, paddle height. Let's make it 15,000. Ball size equals to 15, so quite a small ball. White, and this is the color white. For when we need to add a little bit of color differentiation in the program, black is 30. And FPS will be at 60. So we're just creating these variables, and we're going to use them later in different functions, as well as graphical user interface. Now we're going to get the screen dimension. Screen info equals to pygame.display.info with height of the screen info, current, screen info, current age. Screen equals to Pygame display set mode with height. Along here, Pygame dot full screen. That's very, self-explanatory. We're going to play it in full screen. Pygame display set caption, our title ping pong. Clock equals to Pygame time clock. Player paddle Pygame rectangle width is minus 50, height over 2, paddle height and paddle width and paddle height. All right. Computer paddle. So this one the computer will control, and the player paddle obviously is going to be the user of the program. Pygame rectangle 50, height, paddle height, paddle width, and then paddle height one more time. Now let's set up the ball. Ball equals to Pygame rect, or for rectangle, width over 2, ball size, height to ball size for 2, ball size, and then just ball size constantly. Ball speed x 7 times random choice 1, and then -1. And we do the same thing for ball speed y. 7 times random choice 1, -1. Player score goes to 0. Computer score. Oh, by the way, we're going to reset the score every time the user restart the program. So if you close the program, all of the scores are reset, and you'll start anew on the next session. 0. Font goes to Pi game font none 36. Reset ball. So in case the ball goes out of boundary, it restarts again from the middle, so we can hit it. Ball center width to height to return 7 times. Actually, let me add spacing over here. This should go down here. Return 7 times random choice 1, -1. 7 times random choice 1, -1. Again. Def ball animation. This function will handle the ball movement as well as its collision. Global ball speed x, ball speed y, player score, computer score, ball x, increment, ball speed x, ball y, increment, ball speed y. Let's work with the ball collision. If ball top is less than or equal to 0, as well as ball bottom being more than or equal to height. Okay. We're simply making the program aware of the boundaries, where the ball can go and where it cannot go. Ball speed y, -1. And then we also need to consider the ball collision with the paddles, because we do want the ball, to bounce back after it's interacted with the paddle instead of going through the paddle or not registering it at all. If ball dot collide with rectangle, player, paddle, or ball collide, rectangle, computer, paddle, ball speed x, -1. If ball collide rect, player, paddle, player score 1. Else computer score, well, the computer wins this time. In the case of the ball going out of bound, the score and the ball will be reset. So if ball dot left 0, player score 1, ball speed x, ball speed y goes to reset ball. If ball dot right is more than or equals to width, computer score 1, ball speed x, ball speed y equals to reset ball. Now let's work on the player animation. This will handle the player's paddle movement. Keys equals to pygame.key.get pressed. If keys pygame k up and player paddle top bigger than 0, player paddle y 7. If keys pygame k down and player paddle bottom is less than height, player paddle dot y 7. Def computer AI. So this is the very basic AI that would go up and down in order to hit the ball to return it to you. If computer paddle center y is less than ball center y and computer paddle bottom is less than height, computer paddle y increment by 5. If computer paddle center y is more than the ball center y and computer paddle at top is more than 0, computer paddle y computer paddle y decrement by 5. Now let's work with the main function def main global ball speed x, ball speed y, player score, computer score, while true. For event in pygame event get pygame, forgetting the A here. If event type goes to pygame quit, pygame.quit, system exit. If event type goes to pygame key down, if event key equals to pygame.k escape, pygame also quit, sys exit quit as well. If event key goes to pygame.kr, we'll restart the game. Player score 0, computer score 0, ball speed x, ball speed y, reset ball animation, player animation, computer AI, screen fill black, so the background is black. Pygame draw rectangle screen white, 2 paddles are white. Player paddle. Same thing with the computer paddle. Pygame dot draw rect screen white, computer paddle, pygame Pie game, draw, ellipse, screen, white, ball. Pie game, draw, line, screen, white, width, over 2, 0, width, 2, height. Player, text, font, render, whoops, F, player score, true, white, computer, text, font, render, F, computer, score, true, white, screen, lit, player, text, width, 2 plus 20, and then 20. Okay, high game, display, flip, clock, tick, FPS, if name equals 2, main, there. So this is the extent of our code so far. All right, so this is what it looks like for us. As you can see, there's a score that's keeping track, and the ball starts from the middle randomly, and we can move our own paddle up and down like so. So try to, yeah, we got one score. Oh, okay, so I think it should be, yeah, down here for us. Goes back and forth. As you can see, the ball does bounce back. Whoop, whoop, whoop. The ball does bounce back when it interacts with the top and bottom. However, interacting with the left and right screen is out of bounds, and everything restarts. There we go. If you can anticipate, you know, the bouncing physics from the top and the bottom, I think you can play this game quite well, and naturally you can adjust the size of the ball, the size of the paddle, the background color, and that was a very weird physics over there. So if somehow it gets between the paddle and the left and right boundary, you can see, you know, some very interesting behavior. Okay, and you can entertain yourself like this. I could do this for hours. And when you want to exit the game, simply press escape or ESC, you know, or just switch over to your VS Code and stop it from running. So that's it for today's lesson. Thank you for tuning in. Don't forget to like, subscribe, and comment, and see you next time. Have a wonderful day.